Welcome student to online classes of mathematics for class 8. In this video we are going to study chapter number 6, which is squares and the square root of NCERT textbook, and we'll be covering the exercise 6.2. This is session number 2 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The topic that we are going to study today is finding the square of a number. In the previous class we discussed the properties of square number, also the patterns in square number. Okay, today we are going to learn how we can find the square over any given number. Okay, suppose we have a number, let's say 23, and we are asked to find the square of this number. Okay, so one method is to multiply 23 by 23, that is by multiplication method. Multiplying 23 by 23, you can find the square of this number 23. Okay, but here we can also find the square of this number without doing actual multiplication. Okay, so for that purpose we are going to use two algebraic identity, which are, first one is a plus b whole square, which is given as a square plus 2ab plus b square. Okay, and we have another identity which is a minus b whole square, that is a square minus 2ab plus b square. Okay, using these two identity we can find the square of any given number. Let's say this number is 23 and we are to find the square of this number. So in order to convert this 23 in this form, we can write this 23 as 20 plus 3. Okay, we have written this 23 as 20 plus 3, which is again 23 whole square. Okay, now when you compare this 20 plus 3 with this formula, you will find that a here is 20 and b here is 3. Okay, so applying this identity, we have first a square, that means square of 20. Then we have 2ab, that is 2 multiplied to a here is 20 and b here is 3. Then we have b square, that means 3 square. Okay, so now we have to solve this. The square of 20 is 400, and when you multiply this, 2 into 20 is 40 and 40 into 3 is 120, plus we have square of 3, which is 9. So when you add this 400 plus 120 plus 9 is 529, which is the square of 23. Okay, so by using these two identities you can find the square of any given number like this. Okay, so next topic is other patterns in square number. So we have one more interesting pattern in the square number, which is when we are to find the square of a number having 5 at the unit place, we can use the pattern. Suppose we have a number 25. Okay, that means this number have 5 at the unit place, and the square of 25 is 625. Okay, so the pattern that we have here is, we can find the square of this number. You can see the second digit or the digit at the tens place here is 2, so we'll write 2 and multiply it with its next natural number, which is 3. So 2 into 3 is 6, and we'll write this into 100 plus 25. Okay, so this means 2 into 3 is 6, 6 into 100 is 600 plus 25, which is again 625. Okay, so whenever you have a number having 5 at the unit place, you can use this method to find the square of that number. You can see this next number, let's say 35 square. 35 square is 1 2 2 5. Okay, so like I said, we have this number 3 at the tens place, so write this number 3 and multiply it with the next higher number, which is next natural number, which is 4, and multiply it by 100 plus 25. Okay, this 3 into 4 is 12, 12 into 100 is 1200 plus 25. That means the answer is 1225, which is the square of 35. Okay, you can also find the square of number, let's say 75 square. The square of 75 is 5625. Okay, so this is can also be calculated by, like I said, this we have a 7 at the 10th place, so write 7, multiply it by next natural number, which is 8, and outside multiplied by 100 plus 25. Okay, so we have 5 into 8 is 56, 56 into 100 is 5600 plus 25. So the result is 5625, and so on. You can find the square of any number having 5 at the ones place. Okay, this method is applicable only when we have 5 at the ones place. Okay, so this is another interesting pattern of a square number. Next we have Pythagorean triplet. This is very important topic. You must have heard about the great mathematician called or named as Pythagoras. Okay, we have a great mathematician, his name was Pythagoras. Okay, he has given a very important theorem which is commonly called as Pythagoras theorem. Okay, so in order to understand this Pythagorean triplet, you should first know what is Pythagoras theorem. Okay, the Pythagoras theorem is applicable in right triangle. So let's first draw a right triangle. This one, right triangle at point, let's say B here, and we have C here. So we have right triangle ABC, right angle at B. So Pythagoras theorem says, in a right triangle, this sum of square of the base and perpendicular is equals to the square of hypotenuse. Okay, so we have this base here, this one is perpendicular and this one is hypotenuse. The Pythagoras theorem says, in right triangle, sum of square of base and perpendicular, that means square of base and perpendicular. Base here is BC, we are finding the sum of square of base and perpendicular here is AB. That means the sum of the square of base and perpendicular is equals to the square of what? Hypotenuse. Hypotenuse here is AC. Okay, that's what this Pythagoras theorem say. Or you can write in the symbolic form that base B square plus perpendicular P square is equals to hypotenuse H square. This is the general formula derived from the Pythagoras theorem. Okay, which is B square is plus P square is equals to H square. That is the sum of the square of base plus and perpendicular is equals to square of hypotenuse. Okay, that's what this Pythagoras theorem say. So we have this number B square plus P square is equals to H square. Okay, so there has to be few numbers or the few square number which are going to satisfy this formula of Pythagoras theorem. Okay, and those three number will be called as Pythagorean triplet. Suppose we have a number 3 square plus 4 square, where you find the 3 square is 9, 3 square is 9 and 4 square is 16. When you add these two numbers, you will get 25, and 25 is the square of 5. So the number 3, 4 and 5 forms Pythagorean triplet. Okay, so number 3, 4 and 5 forms the Pythagorean triplet. These are not the only group of number which satisfy the Pythagoras theorem or which are Pythagorean triplet. There are many more such group of number which satisfy this Pythagoras theorem, and hence they will be termed as Pythagorean triplet. Okay, there is a one common method for the formula to find the Pythagorean triplet, that is Pythagorean triplets will be Pythagorean triplet. It says that for any natural number for any natural number m greater than 1. So we have a natural number which is m, and this has to be more than 1. We have 2m square plus m square minus 1 whole square is equals to m square plus 1 whole square. Okay, so this is the formula of the numbers which will help us to find the Pythagoras triplet. Okay, so we can write, so 2m, which is this one, then m square minus 1, this one, and m square plus 1 are called Pythagorean triplet. Okay, so those numbers are 2m, m square minus 1, and m square plus 1. These three numbers are called Pythagorean triplet. Okay, if we are given any number, we can equate that number to this one. So we'll get the value of m from here, then we'll equate the value of m in these two terms. We will get the all three number of Pythagorean triplet. Okay, so based on this we have next exercise, which is exercise 6.2. Before that we have few examples. Let's first look at the examples. So first we have example number 1, says find the square of the following numbers without actual multiplication. So we are here asked to find the square of these two numbers without doing the actual multiplication. So again we are going to use the identity here. So let's write the solution of first one. Part 1, we have number 39. Okay, so this number 39 can be written as, we can write this in two way. First can be 30 plus 9, or we can also write this as 40 minus 1. Okay, in both way, when you find its solution, the result will be same. Okay, so we are asked to find the square of these numbers, so we'll put the whole square on both sides. So you can use either this one or this one. So we are using 30 plus 39. Okay, so let's write this answer as, so we first will write using identity a plus b whole square, which is equals to a square plus 2ab plus b square, we get, okay, now we'll go and write this as 30 plus 39 whole square will be written as, then we have a square, a here is 30, so that means square of 30, plus we have 2ab, that means 2 multiplied by a is 30 and b is 9, then we have plus 9 square. Now the square of 30 is, square of 3 is 9, this 20 will be double, so we have 900. Then this 2 into 8 is 18, 18 into 3 is 54, that is 540, and we have square of 9 is 81. Now the sum of these three numbers will be 1521. Okay, so the square of 39 is 1521. That's the answer. Okay, so we have calculated the square of number 39 without actually doing the multiplication. In similar way you can find the square of second number, which is 42. We have number 42. So the square of 42 can be written as the sum of 40 plus 2. Okay, now again we are going to use the identity. So right, using identity a plus b whole square equals to a square plus 2ab plus b square. Okay, so this will be 40 plus 2 whole square equals to a square, a here is 40, that means 40 whole square plus twice of a into b, a is 40, b is 2, then plus b square, b is 2. Okay, now do the calculation. For 40 square is 1600, This 2 into 2 is 4, 4 into 8 is, 4 into 2 is 16. So this will be 160 plus 2 square is 4. So when you add these three, you will get the answer as 1764. That's the answer for, or that's the square of number 42. Okay, so that's how you can calculate the square of any number using these two identity. Okay, this identity a plus b whole square or a minus b whole square. Okay, so next question is, write a Pythagorean triplet whose smallest number is 8. We are given that the smallest number is 8, so we have to find the Pythagorean triplet. Okay, so let's write a solution to. Okay, so first we are going to write the what is Pythagorean triplet. We know, we will write as we know the Pythagorean triplet, the Pythagorean triplet are given by, we have three numbers, 2m, comma m square minus 1 and m square plus 1. Okay, let's assume this 8 is equals to this 2m. So let's write, let 2m is equals to this given number, which is 8. So from here m will be 8 by 2, or that will be equals to 4. So the value of m here is 4. Okay, so let's find the first triplet, which is already here, that now the 2m is equals to 8. Let's find now m square minus 1, that means square of 4 minus 1. Square of 4 is 16, minus 1 will be 15, and we have to find next square of m plus 1, that is 16 square plus 1, 60. So 4 square is 16 plus 1 equals to 17. Okay, square of 4 plus 1 is equal to 16 plus 1 equal to 17. So the triplet that we got here is, the triplet is, first number is this 8, second number is 15, and the third number is 17. Okay, with as the smallest number. Now moving to the next example, we have example number 3. Here we are asked to find a Pythagorean triplet in which one member is 12. Now it's clearly say one member is 12, so we don't know this 12 is representing 2m or m square minus 1 or m square plus 1. So we'll try with the both one. So let's write its solution number 3. So we'll assume that first we'll write as we know the Pythagorean triplet is given by 2m m square plus 1 and m square minus 1. Okay, so let's take, let 2m is equals to this 12. Okay, we are not given that 12 is representing which of these three number. Okay, we are just saying one member is 12, so we have assumed that let 2m is equals to 12. So from here m will be 12 by 2 equals to 6. Okay, so when you find the other two number, that is m square plus 1, that is 6 square plus 1, that is 36 plus 1 equals to 37, and next number is m square minus 1, that is 36 square minus 1, which is again 36 minus 1 equals to 35. Okay, so these are the Pythagorean triplet. So I'll write, hence the Pythagorean triplet is Pythagorean triplet is 12, which is this number, then we have 35 and 37. That's our answer. So the answer of question number 3 is that Pythagorean triplet is 12, 35 and 37. Okay, now moving to the exercise 6.2. Here we have only two questions in exercise 6.2, and there are 6 parts in question number 1, and there are 4 parts in question number 2. So out of the 6 part of question number 1, I will do only the first 3 part in this video. The remaining 3 I will left for you to complete. Okay, and similarly in question number 2 I will do the first 2 part, and the remaining 2 will be completed by you. Okay, because all of them are very easy and all of them are similar to each other. So easily complete those questions. I'm going to do the first 3. So first number here is 32. Okay, so let's write the answer number 1 part first. We have number 32. Okay, so let's write 32 can be written as, we can write this 32 as 30 plus 2. Okay, so the square of 32 will be 30 plus 2 whole square. Okay, now we'll use the identity. So let's write using identity, which is a plus b whole square equals to a square plus 2ab plus b square. Okay, using this identity we get 30 plus 2 whole square will be equals to, we have a square, a here is 30, that means square of 30 plus 2ab, that means 2 into a here is 30 and b is 2, plus b square, again b is 2, that means 2 whole square. Now we have to solve this. Square of 30 is 900. When you multiply this 2 into 2, it will be 4. 4 into 30 will be 120, and this 2 square is 4. And when you add this number, 900 plus 120 plus 4 is 1024. Okay, so the square of 32 is 1024. Okay, let's see the next one. Now we have next number 35. So we have second part number is 35. We'll solve this in the similar way. Okay, we can write 35 can be written as, 35 can be written as, this 35 can be written as 30 plus 5. Okay, or the square of 35 will be 30 plus 5 whole square. Now again we'll write using identity, which is a plus b whole square, which is equals to a square plus 2ab plus b square. Okay, so this will be 30 plus 5 whole square will be equals to a square, a here is 30, that means 30 square plus 2ab, that is 2 into a is 30, b is 5 plus b square, that means b 5 square. Okay, now the square of 30 is 900, and this will be 2 into 5 is 10, and 10 into 30 is 300, and we have 5 square is 25. When you add this number, you get 900 plus 300 is 1200. It will be 1225, which is the square of 35. Okay, now I'll do the one more part. Let's do the last one now. Okay, the remaining these 3, 86, 93 and 71 will be your homework. Okay, I will do the last one, which is 46. So this is part number 6, which is 46. The answer will be completed in the similar way. So we'll write 46 can be written as, we can write this 46 as 40 plus 6. Okay, so the square of 46 will be 40 plus 6 whole square. Again using the identity, so write using identity, that identity is a plus b whole square equals to a square plus 2ab plus b square. Okay, so that is 40 plus 6 whole square will be equals to a square. A here is 40 plus 2ab, that means 2 into a is 40, b is 6 plus 6 square. Okay, now the square of 40 is 1600. Okay, square of 40 is 1600, then plus we have this 2 into 6 is 12, 12 into 4 is 480. Okay, 12 into 40 will be 480 plus 6 square is 36. Okay, and when you add these three numbers you will get 2116, which is the square of 46. Okay, so I have done the first, second and the sixth part. The remaining three, which is red circle part, are your homework. You will complete them by yourself. Okay, in the similar way. It's very easy, you can easily complete this. Okay, now moving to the next question, we have question number 2. Here we have total 4 parts. Here also I will do the first 2 and the next 2 will be your homework. Okay, so let's see the first one. We have first number is 6. We have to find the Pythagorean triplet whose one member is 6. So let's start. Answer number 2, part 1, we have a number 6. Okay, so first we'll write, we know that the Pythagorean triplets is given by 2m comma m square minus 1 and m square plus 1. So we know that Pythagorean triplet is given by 2m comma 2m m square minus 1 and m square plus 1. So let as in the questions given, one member is this number. Okay, so we know that we don't know which number is represented by 6. Either 6 is representing this 2m, or it can be representing 2m minus 1, or it can also be representing m square minus 1 or m square plus 1. Okay, so let's assume that 2m is equal to 6, which is given number. Okay, so first we are starting with assuming the 6 is given number is 2m. Okay, so from here the value of m will be 6 by 2, which is 3. So m turns out to be 3. Let's find the other two number, that is m square minus 1, which is 3 square minus 1. 3 square is 9, minus 1 will give us 8. And the next one is m square plus 1, that is 3 square plus 1. 3 square is 9, plus 1 will give us 10. So the Pythagorean triplet is these three numbers, 6, 4 and 8. So right, hence the Pythagorean triplet is 6, 8 and 10. Okay, so I will do the one more part, the remaining two will be done by you. So let's take the next number, which is 14. We have number 14. So again we'll write, we know that the Pythagorean triplets is given by the three numbers, which are 2m, second is m square minus 1 and m square plus 1. Okay, so again we don't know which number is this 14 is representing. So we assume that let 2m is 14. So from here m is 14 by 2, that will be equals to 7. Okay, so if m is 7, so next number m square minus 1 will be 7 square minus 1, that is 7 square is 49 minus 1, that is 48. Okay, next one is m square plus 1, so this will be 7 square plus 1. 7 square is again 49 plus 1 will give us 50. Hence the Pythagorean triplet is hence the Pythagorean triplet is 7, 48 and 50. Okay, so that's the answer of the part second of question number 2. So I have done the first two part. I hope you can complete the other two part, that is 16 and the 18. Again equate them to equals to 2m. So from here the value of m will be 8, and from here a value of m will be 9. Okay, with this that you can find the corresponding value of m square minus 1 and m square plus 1. You will get the three number which will be the Pythagorean triplets. Okay, so I hope you've understood all the questions. Now you can easily complete the remaining parts which I have left for you to try by yourself. Okay, so that's all for today. Thanks for joining here. Thank you.